training programme in Flex Inert Gas Generator. If this is the first time you're running this programme, click the Help button. Click the About button for information about the developer of this programme. You have now started training on the subject Flex Inert Gas Generator. After completion of this module, the trainee will answer relevant questions to show his knowledge and understanding of the construction and operation of the Flex Inert Gas Generator. This module would take approximately 60 minutes. On completion of this lesson, you should have a good knowledge of international regulations, definitions and principles, safety aspects. Some information given in this training module is based on the IMO regulation. For detailed information on rules and regulations, please refer to relevant documentation from Maritime Safety Committee. Click the buttons for definitions. Inert gas is a gas or a mixture of gases, such as flue gas, containing insufficient oxygen, such that hydrocarbon vapours ignite. All equipment specially fitted to supply, cool, clean, pressurise, monitor and control delivery of inert gas to cargo tank systems. An inert gas plant and inert gas distribution system, together with means for preventing reverse flow of explosive cargo gases to the machinery, fixed and portable measuring instruments and control devices. An inert gas system is used to prevent tank explosions. Inert gas is introduced into the tanks to keep the oxygen content low and reduce the concentration of hydrocarbon gas in the tank atmosphere to safe proportions. Inert gas cannot support life. It has a negative effect on the human body because of oxygen deficiency, toxicity of hydrocarbon vapours, toxicity of flue gas. Click the words for more information. Exposure to an atmosphere with a low concentration of oxygen does not necessarily produce recognisable symptoms before unconsciousness occurs. The onset of brain damage and the risk of death can follow within a few minutes. When testing for entry into an enclosure, a steady reading of 20.9% oxygen is required. The toxicity of hydrocarbon gas is not affected by the pressure of inert gas. Because of possible gas pockets, gas freeing for entry into a space must continue until a 1% lower value than the lower flammable limit reading is reached for the entire compartment. This reading is detected by using a portable hydrocarbon gas analyzer. When, by ventilating the compartment, a reading of 1% low flammable level or less is reached, as well as an oxygen content reading of 20.9% by volume, the toxic trace gases will be diluted to concentrations at which the compartment will be safe for entry. In order to prevent the possibility of an explosion, the following 3 factors must be controlled. the hydrocarbon gas given off by the cargo, the oxygen content of the tank atmosphere, the sources of ignition. It is impossible to prevent the formation of hydrocarbon gas, and the sources of ignition are diverse and not fully understood. However, by introducing an inert gas into the cargo tank atmosphere, the effective oxygen content can be reduced to a level outside the area where an explosion may occur. On board vessels carrying cargoes which give hydrocarbon vapours, a dangerous situation may arise if oxygen enters the cargo tanks. At this stage, a potentially flammable environment will be formed in the tank, and if a source of ignition is present, an explosion will occur. The explosion. Any point on the diagram represents a hydrocarbon gas, air, inert gas mixture, specified in the terms of its hydrocarbon and oxygen content. On most existing vessels, it is not possible to prevent air from entering the cargo tanks, particularly during cargo discharge. However, by installing an inert gas system, it is possible to introduce suitably treated flue gas into the cargo tank. The inert gas is supplied with a low overpressure and displaces any air present in the cargo tanks. The demand for inert gas appears during cargo discharge, and the supply of inert gas must at least equal the cargo discharge rate. The rated capacity of centrifugal cargo pumps is related to a specified discharge head. When discharging against the lower head, it is possible to exceed the rated capacity. To accommodate this and ensure that the inert gas is supplied at a positive pressure, the inert gas system must be capable of supplying inert gas at a rate greater than at which the cargo is being discharged. A factor of 1.25 of inert gas capacity above nominal cargo pump capacity is the prevailing design criteria. The inert gas system must provide an inert atmosphere within the entire cargo tank. It shall prevent explosive mixture, it shall not contaminate the cargo, and it must be available in sufficient volume and pressure to suit all operating conditions. The system has two basic groups of equipment: a production plant to produce inert gas and deliver it under pressure by means of a blower to the cargo tanks. A distribution system to control the passage of inert gas into the appropriate cargo tanks at the required time. The deck water seal acts as a non-return valve and prevents the backflow of hydrocarbon gas from the cargo tanks, thus avoiding a potentially hazardous condition in safe areas. The inert gas is distributed to the cargo tanks by branch pipes connected to the inert gas deck main line. Each branch pipe contains a valve, so that any tank can be isolated. In the following pages, you will be asked some control questions from this section. Once you've started answering the questions, you have to answer all the questions before you can go back to the menu.